You will write your code with the Microsoft Visual Studio IDE. Download and install the free community version. Ensure the following workloads are installed in Visual Studio. In Visual Studio, create a new project. Choose the console app and then click on Next. Add the project name and a folder to save the project. Keep the solution name and click on Next. Select the .NET framework and click Create. In the code editor, you will see this C# code. It will write the text, "Hello World," in the console window. Run the application. You will see the line of text written in the console window. C# is a strongly typed language. Every variable must be defined by a type. The first type we will be looking at is the string. The string type is used for text. The variable name is of type string and has a value John. Here we use string interpolation to output the value of the variable in the console window. Run the application. You will see the value of the string variable in the console window. The integer type is used to represent whole numbers. The variable x is of type integer and has a value of 1. The variable y is of type integer and has a value of 3. The variable sum is of type integer and has a value of the sum of x and y. We output the value of the sum in the console window. We use the toString method to convert the integer to a string. Run the application. The sum is displayed in the console window. The decimal type is used to represent decimal numbers. The variable pi is of type decimal and has a value of 3.14. We use the letter m to represent a decimal. We output the value of pi in the console window. Run the application. The value of pi is written in the console window. The double type is used to represent floating point numbers. The variable pi is of type double and has a value of 3.141. We output the value of pi in the console window. Run the application. The value of pi is written in the console window. The bool type is used to represent true or false values. The variable b is of type bool and has a value of true. We output the value of b in the console window. Run the application. The value of b is written in the console window. DateTime is used to represent date and time. The variable now is of type DateTime. We use the DateTime now method to get the current date and time. We output the value of now in the console window. Run the application. The current date and time is written in the console window. You can store multiple variables of the same type in an array data structure. The variable numbers is an array of integers. We use the square brackets to represent an array. This array contains a list of numbers. We use the curly brackets to represent the list. The items in the array start at the 0 order. These are the first order, second order, and so on. The variable a is an integer and it is the number at the third order of the array. A is the third order in the array, but it is the fourth number in the list since we start counting at the 0 order. We write the fourth number in the array in the console window. The fourth number in the array is written in the console window. Statements are used to change the flow of code logic. The first statement we will look at is the if-else statement. An if-else statement identifies which statement to run based on the value of a Boolean condition. The variable result is of type string and has a value of the empty string. The variable number is an integer and has a value of 5. If number is equal to 12, we set the result to a dozen else we set the result to not a dozen. We output the result in the console window. This is the result in the console window. These are some common comparators that can be used when you set up conditions. The do statement executes an operation repeatedly while a specified expression evaluates to false. The variable sum is of type integer and has a value of 0. The variable I is an integer and has a value of 1. The do statement executes this operation repeatedly while I is less than 11. In the first run of the loop, I is equal to 1. The sum is the initial sum, which is 0. Then we add I, which is 1. Then I increments to 2. In the second run, I is now 2. The sum is the initial sum, which is 0 plus 1. Then we add I, which is now 2. We get the sum is equal to 0 plus 1 plus 2. The pattern then repeats itself until I is equal to 10. In this way, we are adding all the numbers from 1 to 10. We output the sum in the console window. This is the sum in the console window. The while loop evaluates the specified expression first before carrying out the operation in the loop. Here, we evaluate the expression for I is less than 11 first. Then we execute the loop. The sum in the console window is the same. The for loop provides a more compact statement for the do-while loop. We set the initial value for I, define the expression to evaluate for I, and increment I in one single statement. The sum in the console window is the same. The for each statement repeats an operation for each element in an array or list. The variable sum is of type integer with a value of 0. The variable numbers is an array of integers that contains all the numbers from 1 to 10. The for each loop goes through each number in the array and adds them one at a time. In this way, we could get the sum of all the numbers from 1 to 10. We output the sum in the console window. Here is the sum in the console window. We are going to apply what we learnt about C# types and statements to create a console application. A school has a number of exams in a term for a course. Each exam has a maximum score of 100. We would like to calculate the average mark of the exams and determine if a student passes the course. We need to gather the exam marks data in the console window from a user, and then calculate and display the student's result and the average mark based on the user's input. First, we collect the exam marks from the user's input in the console window. We declare a variable number of exams of type integer and set the initial value to 0. We write a line of text in the console window asking the user to enter the number of exams in the term. We read the input from the console window. Since the input in the console window is a string, we need to convert it to an integer. We store the value in the number of exams variable. Now that we have the number of exams in the term, we need to get the individual exam scores. We declare an array of integers called exam marks. We set the size of the array to be equal to the number of exams for the term. In this way, we can store each individual exam mark in the array. We use a for loop to get each exam mark from the user. We set up the for loop, where I equals 0 to I less than the number of exams, then increment I. Each time the loop runs, we ask the user to enter the individual exam mark. We use I plus 1, since the array starts at order 0. We read the user input from the console window one at a time. We convert the value from the console window to an integer. We store each individual exam mark in the array of exam marks. Let us run the application to see what we have accomplished thus far. We enter the number of exams for the term. Then we start entering each individual exam score using the for loop. The program exits after the for loop is complete. Now that we have collected the individual exam marks, we can now calculate the average mark for the course. We declare a variable total marks of type integer and set the initial value to 0. We use a for each loop to go through each individual mark in the array of exam marks and add them up. We store the sum of all the exam marks in the total marks. We declare a variable average mark of type integer. We calculate the average mark by dividing the total marks by the number of exams. Now that we have the average mark, we need to determine if the student passes the course. We declare a variable result of type string and assign the initial value to the empty string. We use an if-else statement to set the value of the result to pass or fail depending if the average mark is more than or equal to 50. Finally, we display the result and the average mark to the user in the console window. Run the application. Let's take a look at AI. Let us use GitHub Copilot to help us write the code. We will write a prompt for the AI to develop a console application based on the specification in the comments section of the program.cs file. The AI is reading the specification and will start writing the code. We will accept the final code. Let's take a look at the AI reasoning. It will allow the user to enter an exam mark from 1 to 100. It will calculate the average mark. It will display pass or fail based on the average mark. Let's check the code. A header is provided for the title of the application. The user is prompted to enter the number of exams for the term. The value is read from the console window and converted to an integer. The value is stored in a variable number exams. The input is validated to ensure the value is more than 0 and is a valid number. A message is provided to the user if the input is invalid and the program exits. A list of integers named marks is used to store each individual mark. A for loop is used to collect the marks. The while loop is used to collect and validate each mark. We ask the user to enter an exam mark. We read the value from the console window and convert it into an integer. The mark is saved in the variable. The mark must be more than 0 and less than 100. If the mark is invalid, a message is provided and the mark is set to -1. The while loop will then reprompt the user to re-enter the mark. This line of code seems to be unnecessary here. If the mark is valid, we add the mark to the list of marks. We use a for each loop to go through each mark in the list of marks. We add each individual mark and store the total marks in the variable average mark. We divide the total marks by the number of marks and store the value in the average mark. If the average mark is more than or equal to 50, we set the variable result to pass. Else we set the result to fail. Finally, we display the average mark in the console window as a decimal with 2 decimal places. We also display the result. Run the application.